The next section we're going to look at is 3.3, characteristics of polynomial functions in factored form. We have already looked at general characteristics of our functions based on some information that's given to us, like the degree of the function, whether it is the number of turning points, the number of possible zeros. Now we're going to get into a bit more detail, which this whole chapter will be slowly working towards getting a more accurate graph every single time, every single section as we go on. So far we know the number of turning points and we know the number of zeros. And we know the end behaviors. We're going to now look at what other information we can get once our function is in factored form. Now before we do that, I want to understand the behavior of some of these functions, and because I'm going to talk about this a bit, so I want to make sure we remember. So x minus 1 is a function that goes through as a line, right? X minus 1 is a linear function. When it's squared, right, it is a parabola that goes through 1. But it's negative, so it's opening down. X minus 1 cubed with, again, a negative. It goes through 1, but it's been reflected, so now it's going that way. It's been flipped upside down, so it'll just be going down this way. And then x minus 1 to the power of 4, right, it is to the power of 4, so the behavior is going to be quartic. So it will be very wide, like a parabola, but wider. What we're looking at here is what each of these exponents does to the behavior at the x-intercept. So if we look at the first one, is to the power of 1, is a linear function, so it passes through the x-intercept as a line. Number 2, it's a parabola. So when I go to the x-intercept, it'll be very parabolic in its behavior. X minus 1 to the power of 3, it's a cubic function. Oops. So when it passes through my x-intercept, it passes through in a cubic form. Like it's a very cubic graph that's going. It's not a straight line, it has the curve in here. Number 4, if it's to the power of 4, it is, again, passing through that 1 with a wider parabola, so it's more of a quartic, it's a quartic function in that sense. What we're going to do now is we're going to combine all of these into one single graph, and to see that what characteristics do we discover based off a function that is given to us in factored form. Okay, so what we're going to do now is we are going to graph this function using what we know about factored form, about behaviors at the x-intercept based off of the exponent that exists that we just went over, and what else we learned in 3.1 and 3.2. First thing is the degree of this function is going to be 3, 4, 5 plus 1. It's going to be 6, because this is x squared, x cubed. Once you multiply them all together, you'll get x to the power of 6. We have a positive leading coefficient, right? And we know that this is an even degree function. Because it's an even degree function with a positive leading coefficient, what I know is that as x approaches positive and negative infinity, y will approach positive infinity. With all that information here, we're going to go ahead and draw what we can of our graph. Let's put down what we know. We know the roots, the zeros of the function are going to be 3, 0, negative 4, 0, and 1, 0. So there's 1, there's 3, and there's negative 4. The other piece of information that we can figure out is the y-intercept. The y-intercept when x is 0. If we make x 0 in all of them, we'll have 3. So negative 3 multiplied by negative 1 is positive 3, multiplied by positive 4, which is being squared, so multiplied by 16. So 16 multiplied by 3 will give us 48. So the y-intercept here would be 0 and 48. We'll go ahead and label that. That is our y-intercept. With all that said, now we can start graphing. Sorry, one more thing. We know the end behavior is as x approaches positive and negative infinity, y will approach positive infinity. So I know my graphs eventually have to end up at the top. Easiest way to do this is start at the left and let's move right. First intercept is -4. The behavior at -4 is parabolic. Well, it's coming from top, so it needs to continue, and it'll have to be a parabola here. That's what we talked about right before we did this question. The next intercept is 1. At x equals 1, the behavior is cubic. And I know that it's going to have to go up to the top, it's going to hit the y-intercept, and it's going to come down. So the graph will be coming through here, and it'll have to go through in a cubic manner. Finally, at x equals 3, the degree is 1, so it's just going to be a line going through here. With all this said, we don't know what's happening in between any of these x-intercepts, other than the fact that there's a y-intercept at 0 and 48. At the very ends, the extremes, they need to approach positive infinity. So let's go through and connect our graph. Remember, these are sketching. Right, so there'll be a sketch. The graph goes like this. I can go up. It has to go through the y-intercept, connect here, go down. I can have it now connect back. As long as it passes through 3 as a line, passes through 1 in a cubic manner, and passes through -4 as a parabola, and we have a y-intercept of 0.48, there is a possible graph of what this function could look like. Absolutely, we could have turned it into a smaller parabola here. We could have had it go down further. We don't know what's happening in between here. All we know is that it's to the power of 6. We know that it's an even degree function. We know that it has to open up. We know the behavior at the zeros, and we know the y-intercept. And we use all of that information to provide or to create one possible version of this graph.